Hello, so today we're going to be covering surds. So what is a surd? A surd is an irrational number. A surd is an irrational number. Now, let's see what we mean. When you get the square root of 4, the square root of 4 is plus or minus 2. But now when you get the square root of 2, for example, and you put it into a calculator, you're going to get an answer in points. So we can either choose to get that answer in points and maybe round it off to 4 decimal places, or we can choose to work with it as just the square root of 4. Now, if you're working with it as the square root, as the square root of 2, you can now work with it in form of surds. So now, before we start looking at examples, you're going to see a few properties of surds. So this is in multiplication. If you have any surds multiply, maybe root of a times root of a, you just multiply what is inside. So this becomes root of a squared. You see. Then if you're dividing surds, this becomes root of a out of b. What else? Now here, this is going to be a very important relationship in this chapter. So understanding that a plus b squared is going to be a squared plus 2ab plus b squared. Then a minus b squared is going to be a squared minus 2ab plus b squared. Now this can be obtained from the normal expansion. Okay, so we say what is a plus b squared? So what is a plus b squared? This is going to be a plus b into a plus b. So you can expand this by saying a into a plus b into a plus b. What does this become? A squared plus ab plus ab plus b squared. So this becomes a squared plus 2ab plus b squared. So this is a plus b squared. So why do we want to have these relationships like this? Because in case, let's say, just by comparing, if I have something like p plus q squared, I don't have to re-expand it. I can now just compare and say p, whatever is happening to a here will happen to p. So I say now this is p squared plus 2 times pq plus q squared. So this is the relationship we're going to be using. So that's the same thing for this. When you expand it, you get that, but we're going to be using this relationship in very many expansions where we cannot again re-expand like this because of maybe the expansions being very big. We can now just quote this and now copy using the relationships. Then now another property is that when you have the root of a, this is the same as a to power half. When you have the root of 3, so yeah, this is the cube root. It's the same as a to power. So meaning nth root of anything can be written as a to power. And that's another law we should do. Then another thing is that if I'm multiplying such, for example, I have 3 root of a times 6 root of b. I multiply the numbers alone and the surds alone. So this 3 times 6, I'll get 18. And then I also multiply this, I get a times b. So this is another relationship that is important. Okay, now with this, I think we can now start looking at examples. Alright, so now let's look at this example saying simplify this in the form of this, where P and Q are rational numbers. So we have this. So we have root of 3 minus 2 out of 2 root of 3 plus 3. So the first step, we have to rationalize this. And how do we rationalize this? The first thing we do, we take the surds out of the denominator. How do we do this? We're going to get the conjugate of this, like we generate another term here with 2 root of 3 minus 3. Then we also put it up. By putting it up, it's like we've neutralized it. So if this and this can cancel out, it's like we have not changed the equation. So now we are going to open both these brackets. So opening the ones up, we'll have root of 3, 2 root of 3 minus 3 minus 2 into 2 root of 3 minus 3 out of, even down here we can open the same, though I'm going to show you what I mean, but when you look at that, you can already see that it's a difference of 2 squares. So here, what do we have? 2 root of 3 minus 3. So now we start opening the bracket. This is going to be 2 into root 3 times root 3. Root 3 times root 3 is going to be root of 9 minus 3 root of 3 minus 4 root of 3 plus 6. Out of here, we're going to have 2 root of 3 times. So this is going to be 2 root of 3 squared. Then we're going to have minus 6 root of 3 plus 6 root of 3 minus 9. So this is what we have. Now we're going to break this down. But here we see that the root of 9 is 3. So it's like we have 2 times 3, which is 6. So this is 6 minus, and then 3 root of 3 minus 4 root of 3 becomes 7 root of 3 plus 6 out of this square. So this is the same as saying 2 squared times root of 3 squared. This, then now this goes, so we have minus 9. So here we end up having 6, so we have 6 plus 6, this is 12 minus 7 root of 3 out of, so this is 4 times, this cancels with this is 4 times 3 minus 9. So what do we have? 12 minus 7 root of 3 out of 12 minus 9. So what do we have? 12 minus 7 root of 3 out of 3. So what do we end up having? This 12 out of 3 minus 7 out of 3 root of 3. So we have this is 4 minus 7 root of 3. 7 out of 3 root of 3. So you realize here those are the answers we have in the form of p plus q. So what is p? P is 4. What is q? Q is negative 7 out of 3. So now worked out this. Now what did I want to talk about? Difference of two squares. That if you have, let me change the color of this pen. That if you have something like a plus b into a minus b, that you have this is this plus this, usually this becomes difference of two squares when you expand it. So that's the same thing we had here. We have this and then this, but with a minus. So this becomes a difference of two squares. So this could have been written as 2 root of 3 squared minus 3 squared. So going forward, anytime we meet something like this, we're not going to expand like this. We're just going to put difference of two squares. Similarly, when we find an equation expanding as a plus b squared, this is going to be a squared plus 2ab plus b squared. So these are the things I want us to have in our mind, that this is the difference of two squares. Then when you get a plus b squared, this is what you get. So let's look at a few more examples, then close the chapter on surds.